Okie dokie. In this problem, we are given a function of x and y, and the goal is to identify which of these ordered pairs is a critical point of this function. A critical point we will find by finding the first derivative with respect to x, finding the first derivative with respect to y, and we're going to find the x and y values that make each of these, or both of these, equal to 0. And whichever x and y pair makes both of these equal to 0 will be our critical point. So let's talk through the derivative. So we have e to the something. Anytime we have e to the something, that entire e term should stay in our derivative. But then that's the derivative basically of the outside, so we need to multiply by the derivative of the inside, the exponent. So the derivative of that exponent with respect to x would be negative 4x minus 1. The 2y squared is treated as a constant, and so its derivative goes to 0 when we're taking the derivative with respect to x. So now we do just the opposite, and we take the derivative with respect to y, and so the e term, again, will just be repeated in our derivative. But then we take the derivative of the exponent, the inside, with respect to y. The x terms will be treated as constants, which have derivatives of 0, and 2y squared goes to just a derivative of 4y. So then we can ignore the e terms because there's no x and y values we could plug into either of these that would make these e terms equal to 0. So if fx is going to be equal to 0, it's not going to be because of the e term, and same thing with fy. Fy will not be ever equal to 0 because of this e term. It's all going to be based on this the second factors being equal to 0. So that's what we'll do. We'll set these equal to 0, and we'll solve for x and y. So we get negative 4x equals positive 1 once we add it over. Divide by negative 4, and we get x equals negative 1/4. And then here we could basically divide by 4 on both sides, but we'll still get y is equal to 0. So we're looking for an answer, x equals negative 1/4 and y equals 0. So we break out the eraser and we see that A is our best answer.